tell me what inverse operation actually means? Go ahead, Manisha.
Means to undo operation on the variable.
Yeah, it means to undo the operation that was being performed on the variable. So operations undo each other. They're not opposites of each other. They undo each other. Okay, so that's how we want to think of it. We want to reserve the word opposites for meaning two values that are equal distant from 0 on the number line. That's what opposites means. Inverse means something that undoes, an operation that undoes another operation. So when we talk about the inverse operation of multiplication, what is it? It's division. Yeah, so we're going to, whenever we want to undo multiplication, we're going to use division. Now, we don't always have to undo multiplication with division, though. Okay? So just like I think you should have discovered back in lesson 1.2, you don't always have to undo addition with subtraction. Sometimes you can use addition to undo it because you add the opposite. So the inverse operation of multiplication is division, and what is it of division then? Division. Multiplication. They're inverses of each other, aren't they? So when we talk about undoing, we know that these guys are inverses of each other. We can't undo multiplication with addition. Even though multiplication is like a shortcut of addition sometimes, we can't undo it with addition. So we want to talk about it as what kind of operations undo each other. So review. This is something that we should already know without our calculators, okay? Don't use those calculators unless you're really need to. When multiplying or dividing two numbers with the same sign, so in other words, a positive and a positive, or a negative and a negative, the answer is always what? What's the answer always when you multiply with two numbers of the same sign, or you divide with two numbers, Brendan?
Positive.
Always a positive answer. Always. So a positive times a positive is a positive. A negative times a negative is a positive. Same thing with division. And the reason that they have the same rules is because they're inverse operations. When multiplying or dividing two numbers with different signs, so one is positive, the other one's negative, and by the way, it doesn't matter which one is, but one of them's positive, the other one's negative, the answer is always what? Negative. It's always negative. You can always count on that. And again, that's with both multiplication and division because they're inverse operations. Okay, let's see if we can answer this one. The product of any number and its reciprocal is always 1. John can answer it for us. 1. When you take a number and multiply it by its reciprocal, you should always get 1. If you don't have the reciprocal. So what does reciprocal mean? How does a reciprocal look like, maybe? Is John? Okay, you have the number 1/3, 1 over 3. Its reciprocal is 3 over 1. Yeah. And when you multiply 1/3 times 3 over 1, you will get 1. 3 times 1/3 is 1. Okay, so let's solve. We have c over 8 equals negative 7. C is being what? What's happening? C is being divided by 8. That's the one that we need to look at that fraction bar and say, oh, that means division. So C is being divided by 8. So what do we need to do to both sides to undo that division? By 8. Multiply. We need to multiply both sides by what?
8.
By 8. You undo the multiplying or the dividing of 8 by multiplying by 8. You undo multiplying and dividing with each other. Okay, so let's take both sides times 8. 8 times, remember we're using the multiplication dot always now. And we take 8 times the other side also, and we leave our calculators put away. And this is a fraction over here, so I can make 8 into a fraction on the left side by just putting it over 1. What happens when you multiply fractions? How do you multiply fractions? Do they have to have a common denominator? No, not for multiplying, you don't. You can simplify before you multiply by seeing, is there anything that divides in upstairs that also divides in downstairs? Well, 8 goes into itself once, down, oopsie, that should not be an 8, that should be a 1. Let's get that out of there. Okay. So we have one times C upstairs, what is that? C. 1 times 1 downstairs, what's that? 1. What's C divided by 1? Just C, yeah, just C. And so C equals, oh, now we gotta take 8 times 7. Maybe the first question you should always ask yourself is this: what's a positive? In this case, we have a positive times a negative. So what's a positive times a negative? A negative. And what's 8 times 7? 56. There's our solution. Okay, let's do a mental math check problem. What would we do to check this? What would we do to check this? Cameron? We just solved it for C, and we say that C equals negative 56. Tyler?
Negative 56 divided by 8.
Yeah, we would put negative 56 in for our C, and we would see if it works. Negative 56 divided by 8. A negative divided by a positive is a negative, and 56 divided by 8 is 7, so we would get a negative 7, and the other side says negative 7, so it would check out, wouldn't it? So we can still do check problems. Okay, you go ahead and try the, well, let's do this first. Let's talk about that one, because it's got that negative sign in front of the x over 3 on the other side. What can we multiply both sides by that would undo the dividing by 3, and it would take care of that negative sign? Sage? Negative 3. We could take care of both things at the same time, because that variable has to be a positive one of them. So we got to take care of this. We got this negative sign here, and we got the fact that it's being divided by 3. So let's multiply both sides by negative 3, because a negative times a negative will make it positive, and multiplying by 3 will undo that division. So we're going to take both sides and multiply by a negative 3. So we'll take the left side and multiply by a negative 3. And I'm going to just give that negative sign to the x. By the way, when there's a negative sign out in front of a fraction, it can be assigned to either the numerator or the denominator. One of them can have it. They both can't, but one of them can have it. So give it to the one that makes it handy for you. Okay, what's a negative times a negative? Positive, so that's 3 times 4 is? 12. And over here, this negative times that negative will become positive, and the 3's will cancel out, so what will it be? Just x. There's our solution. Okay, let's go back to the beginning and make sure it works. Let's put that 12 in that x. We have a 12 divided by 3. What's 12 divided by 3? 4. This negative sign out front can really say this. Make sure you understand this all year long. A negative sign can also be read as the opposite of. So if we put 12 in here for x, we have 12 divided by 3, that's 4. What's the opposite of 4? Negative 4. The opposite of 4 is negative 4, and that's what we have on the other side. So we have a good solution. Okay, questions? Okay, because you know where students have the hardest time with this is showing, how do you show the word to this? For some reason you get the answer, but you can't figure out how to show the word correctly. So does anybody have concerns about how to do that correctly at this point? Okay, then let's go to the back side. Then solve negative 15 equals 4y. Y is being multiplied by 4. So, what are we going to do? Divide both sides by 4. Okay, so negative 15 divided by 4. I use the fraction bar typically to show division. In algebra, it's just easier, it seems like. Well, sometimes that denominator does not go nicely into that numerator. Is this one of those times? that mean we need to use our calculator? No. Okay, so we have two options here. We can say negative 15 over 4 can't be divided out to a whole number, so we're going to, or into an integer, I mean, so we're going to leave it as a fraction and say negative 15 fourths. But then we could say, is that a simplified improper fraction? In other words, without changing it to a mixed number. Is there anything that goes into 15 that goes into 4 besides 1? Anything that goes into 15 and also goes into 4 other than 1? No. So this, we could leave the answer as a, so we could say our solution could be this. This is one way I could accept the answer. Or a negative 15 fourths is the same as a negative what? 3 and 3/4. There are 3 4s in 15. That's 12. 3 left over to get to 15. So a negative 3 and 3/4. Same thing. Now, typically, the reason why we like to leave them as improper fractions in algebra is for checking. Which one would be easier to go back and check with without your calculator? Which one would actually be easier to check with? The negative 15 fourths or the negative 3 and 3/4? Can you tell me why the negative 15 fourths would be easier? In other words, let me set it up and let's see what it looks like. If we have negative 15 equals 4 times negative 15 fourths. Why is that easier? Because what? Okay, what happens? Well, they're not really reciprocals. Oh, remember on the front when we were undoing division, we were multiplying by what it was being divided by, and then we were canceling because there was one up and there was one down. Isn't that what's going on here? Isn't there one up and one down so we can cancel them out? And we can see, oh, we have a negative 15 left, and over on the other side, it's negative 15, so it checks out. So typically, the improper fraction is actually easier to check with when we have to do a check run. Then, because I don't want you using your calculators like, fourth graders do. Maybe even fourth grade do. Okay, let's do negative 2/3 m equals 6. M is what? Being multiplied by negative 2/3. Okay, I need all of you who aren't awake yet for this Tuesday morning because of the 3-day weekend. I need everybody in here to tell me what you would do next. Don't look at my notes. What would you do if you were solving this problem? You'd say, oh, m is being multiplied by negative 2/3, so I need to, John, divide by negative 2/3. Okay? Well, that's all cool as long as it divides nicely. So if I'm going to divide both sides, I'm going to just do it over here. If I'm going to take negative 2/3 m equals 6, and I'm going to divide both sides by, this is what you would show me on your paper, I already know. And then, I know you would then put it in your calculator and let your calculator do it. Anybody want to own up to that? That is exactly what they would do. Yeah. But we're not going to do that. So, if you can divide nicely, in other words, if it goes like this, I'm just going to do this side over here, the 6 divided by negative 2/3. 6 divided by negative 2/3. Okay, if you can divide nicely, go ahead, go for it. Okay, well, by the way, you can't do any canceling in division. You can't do what we do in multiplication where we get to cancel. We could say that 3 goes into itself once and it goes into that 6 twice, and in fact, if you tried it, I'm pretty sure, let's see, what would we get? 6 over 1 divided by negative 2 over 3. If we said this is okay to do this, 3 goes into itself once, goes in here twice, we'd have 2 divided by negative 2. What would that be? Negative 1. Okay, so then we're saying the solution is negative 1. Let's go back up here. Negative 2/3 times negative 1. What is that? Positive 2/3. Oh, not 6. So we have to be really careful about, we cannot undo, I'm going to undo all that. We cannot do that with division. We can only do that canceling thing with multiplication. We have to just go straight across. 6 divided by -2. What is 6 divided by -2? -3. 1 divided by 3. 1/3. Are we getting anywhere? You feeling kind of like, you know what? So here's what I mean by divide nicely. I bet a teacher taught you somewhere along the line that when you divide with fractions, you have to change it to multiply by the reciprocal. Is that what they taught you? You have to change it to multiply by the reciprocal. You don't have to. You only do when it doesn't work nice like this one. This one doesn't work nice. It can't be divided nicely. Sometimes they can be. So don't be fooled that you have to change it to it. But in this case, you know what? It didn't work very well. So let's go back and multiply both sides by the reciprocal of -2/3. What is that? And would it be positive or negative? Okay, remember now, a number times its reciprocal has to get you a +1. So -2/3, its reciprocal, you're telling me is 3/2, but right now we're having trouble deciding if it should be positive or negative. So the 2/3 is negative. 3/2 has to be negative, so it'll end up being a +1. So if a number is negative, its reciprocal is negative also. So -3/2 times -2/3 m, -3/2 times 6, and I'll make 6 into a fraction. And this is going to work pretty handy on the left side because a negative times a negative is a positive, and these 3's will cancel, and these 2's will cancel, and presto, we'll have m all by itself. Because a negative times a negative is a positive. Ooh, we want a positive m. 3/2 times 2/3 is 1. We can see why, because we got 3's up and 3 down. We got 2 up, 2 down. That's why. Okay, now we can do the other side. We have 2 ways we could do it. We could simplify before we multiply or simplify after we multiply. How many of you like to simplify before you multiply? Yeah, me too. I need to have big 2 and 2 big numbers after. So simplifying before looks like what? What could I do? Cross out the 2 and make it a 1, and what do? Does 2 go into 3? No, not very nicely. How about the 6? And it goes in there 3 times, right? Now I just got 1's downstairs, dividing by 1. So I have a -3 times a +3. -3 times a +3. A negative times a positive is a negative, and 3 times 3 is 9. So this is -9. I will not accept this kind of work over here. That tells me you're using the calculator. And I don't want you using the calculator. So multiply by the reciprocal, or see if you can make it into a nice division problem. Let me give you an example of what I mean. That's a good division problem that works. If I want to take 1/4 and I want to divide it by 1/2, is that a nice one? In other words, would it work out nice? 1 divided by 1 is 1, and 4 divided by 2 is 2. So that one works out nice. So when they work out nice, then it's okay. But if they don't work out nice, that's when we like to do the multiply by the reciprocal thing. So you can do this, okay? So let's go back to our last problem here. This is another one that oftentimes trips students up. They don't know what to do when they see a problem like this. It's written -5x, that's being divided by 6. That's equal to a -2/3. Anybody know another way we could write that would make it probably a little more user-friendly? John, what do you think? How are we going to simplify? when that variable is upstairs, this is careful, listen carefully. When the variable is upstairs, it can be pulled out. It can be pulled out. So we have this x that can come out, and we can really rewrite this like that. Okay? That's how we can rewrite it. And it's going to be actually help us then decide what operation we can do. We only want to do one thing. We're trying to shorten only one step. There are other ways to go about solving this equation, but today this is what we're going to do with it. So now anybody want to suggest what we should do? I know John's awake, but I'm not sure what the rest of us are. I'm calling you Johnson. What should we do to solve this? Alright? Okay, multiply by the reciprocal of negative 5/6. Or by negative 2/3. Which one? Negative 5/6. We want to look on the side where the variable is, and we want to say, I need to undo that. So I'm going to multiply by the reciprocal of negative 5/6, which should be negative 6/5, right? So negative 6/5 gets multiplied times both sides. Oops, I didn't have to put my negative sign here. Kind of an important negative sign there. Okay, so I get negative times negative on the left side, that is a positive. And a 6/5 times a 5/6, they're reciprocals of each other, so what does that create? A 1, and we want a 1, and we want a 1x, so we say, okay, we have x alone. Negative times a negative on the right side also, what's that? Positive. Do you want to do some canceling before we multiply? Or some simplifying before we multiply? Okay, what can we do? That 3 can go into itself once. And 2 times into 6. Okay, anything else we can do before we multiply? Okay, 2 times 2 upstairs? 4? We already decided that a negative times a negative is positive, so we've already not going to worry about the signs anymore. And 5 times 1 downstairs is 5. There's our solution. Now, you give me that in a decimal answer, what am I going to have to assume you did? Calculator, because chances are, not always, but chances are the calculator would give it to you in a decimal. So, we're not using our calculator. I'm going to try and do this without. So, any questions? Okay, could this be checked? Yeah, it could be checked. It would be a little bit more work in this one to actually have to check it, but it could be. Okay, let's get some loose leaf out.